All right, this is Module 1, Lesson 13. We're going to be computing actual lengths given a scale drawing. So let's look at the first example. It says, Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install half-court design as shown below. After checking with school administration, he is told it will be approved if it fits in the empty lot. It measures 25 feet by 75 feet on the school property. Will the lot be big enough for the court he planned? Explain. All right, so here's the design he came up with. The first question says, what is the scale? Now, scale is different than scale factor. A scale is usually listed on the map to tell us what the scale drawing units represent in real life. So up above here, it says 1 inch in the drawing corresponds to 15 feet in actual life. That's the scale. So 1 inch equals 15 feet. That's not the scale factor. The scale factor is what you use to figure out the dimensions. So to find the scale factor, both dimensions need to be the same units, okay? Because remember, you can't have inches and feet in the same thing. So we're going to change 15 feet into inches. Now remember, there's 12 inches in a foot. So we're just going to do 15 times 12. So that tells us that 15 feet is actually 180 inches. Now we can find the scale factor, okay? So remember yesterday we were talking about how we can create a table to find the scale factor, and we would do original compared to the drawing. Now, the original is the actual, what it actually is in real life. So in real life, it is 180 inches. The drawing is only 1 inch. I got that from the scale up above. So if this is X and this is Y, scale factor is the same thing as K. So Y divided by X will be 1 divided by 180. So that means that the scale factor tells us that since it's smaller than 1, the drawing will be smaller, or a reduction of what actually is going to happen, which makes sense because we're not going to put 25 by 75 feet on a sheet of paper. So here's our scale factor. All right, so let's go to this page. It says create a table that shows the measurements of the scale drawing and the actual court dimensions. So we already have in the actual court length, 180 inches is 1 inch. Now, we also know from the diagram on the page before that the dimensions of the court are 2 inches by 1 2/3 inches. So those are my two dimensions. This is my scale. This is my two dimensions. All right, so how are we going to find the actual court lengths? Well, yesterday we said we could just multiply to get the scale drawing lengths. So we would take this actual length times the scale factor. Now, if we're given the scale and we want to go to actual, we're going to just do the opposite of that. So if we're given the scale and we want the actual, we're just going to divide by the scale factor. So for this one, the scale factor is 1 over 180. So we're going to take this and divide by 1 over 180. So take your calculator, 2 divided by 1 ABC 180, which is 360. Now, don't forget we're still in inches. Okay, so that's really an odd number if you think of it in feet, because it's not 360 feet. It's 360 inches. But we know that there are 12 inches in a foot. So if you divide that number by 12, that will give us 30 feet. So actual court length would be 30 feet. All right, so let's do the next one. We have 1 2/3 divided by 1 over 180. So 1 2/3 divided by the scale factor gives us 300 inches. So divide that by 12, and it gives us 25 feet. Okay, so we have the actual length as a 30 by 25. He said he can do it as long as it fits on that concrete pad, which is 25 by 75. So will it fit? Yes, because it is smaller than that. So yes, it will fit. All right, now before we go on to the next example, I need to remind you how to change units in the metric system. You probably did this a little bit in science class. Remember, the metric system is meters, liters, and grams, which is the units part of this. This is our prefixes to go along with kilo, hecto, deci, deca, deca, deci, centi, and milli. So we're going to change by just sliding our pencil along these lines. I'm sure you've heard of King Henry doesn't usually drink chocolate milk. That's a way you can remember these. So if we're talking about meters, that means we're starting at the U. So we want to go to centi. So I would go 1, 2 spots. Notice I'm going to the right. So if the decimal place is after the 4, as it is in all whole numbers, we're going to go 2 spots to the right, which would be 400. This one gives us the milliliters, which would be this one. And I want to go to centimeters. So notice it's 1 step to the left. Remember, the decimal place starts at the end. 1 spot to the left would give us 8. That's just a little reminder because next example, we are going to need to convert in the metric system. All right, example 2. The diagram shown represents a garden and the scale is 1 centimeter for every 20 meters. Each square in the actual drawing represents 1 by 1. So each one of these squares is 1 by 1. The actual length and width of the garden we're going to find the actual length and width of the garden based upon the given drawing. All right, so we read the scale drawing that's up in the problem. It's 1 centimeter, which is 20 meters, but we can't do it when they're in separate units. So let's change 20 meters to centimeters. Remember, it's King Henry doesn't usually drink chocolate milk. So we're going from centimeters to meters. That's not the M, that's millimeters. It's the U for meters. 2 spots to the left. We're going from meters to centimeters. So that's 2 spots to the right. Meters is the U, centimeters is the C. So 20, here's the decimal point, go 2 spots, fill them in. So this would be 20,000 oh my goodness, 2,000 centimeters. All right, so let's do our scale factor. Remember, it's K equals Y divided by X. Remember, Y is always our drawing. X is always our actual. That would be a good way to remember it if you put the little box around it like we used to do when we did unit rates. So our Y is going to be the drawing, and that's the 1 centimeter in the drawing. And the actual is the 2,000 because you want both of them to be centimeters. And if you want to label that first and then cross them off, that would be great. But you don't use the labels once you come up with your K. So here's your K, your scale factor. So this drawing is actually smaller than what it is in real life, which makes sense. All right, so let's fill these in. We have the drawing and the actual. Yes, this looks weird because they put Y on top. Okay, but remember, drawings are always our Y value. So the scale is going to be, in our drawing would be 1, and in That's centimeters. And the actual would be 2,000 centimeters. Now, if you go up in our diagram, we could count the length and the width. Remember, every box is considered 1. So 1, 2, 3, 4, 5, 6, 7, 8. So this has a length of 8 centimeters. You can label it if you want. The width would be this spot right here, which would be 4 centimeters. And we want to find the actual. So when we're finding the actual, remember you're going to divide by the unit rate, not multiply. So we're going to take 8, and we're going to divide it by 1 over 2,000. So 8 divided by 1 over 2,000, which gives us 1,600, and we're still in centimeters. Now, the actual lengths are usually going to be in meters. So we would just be moving that decimal place 2 units back to the left, which gives us 160 meters. All right, let's do the same thing for this. This is 4, and I'm going to divide it by the K value, or the scale factor. When I do that math, I get 8,000. Remember, that's centimeters, so if you want to change it back, that would be considered 80 meters. So the actual lengths are 160 and 80. All right, example number 3. A graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given here so that 0.25 inches on the scale picture corresponds to 1 inch on the actual advertisement. What is the length and width of this tablet on the advertisement? So scale, if you go back up and read, I believe it said right here. So the scale is going to be 1 inch equals 0.25 inches. All right, what is the scale factor? These are both already inches. So K is going to be Y divided by X. Remember, this is our drawing divided by actual. So our drawing, okay, it's 0.25 inches. And the actual would be 1 inch. Now the inches are gone, so it's just 0.25 as our scale factor. All right, so now let's find the actual width, length and width. If we're finding the actual, we're just going to divide. So if we want to make that chart, we would do, I like doing the drawing first since that's our X compared to actual. So the drawing would be 1 1/8 and 1 1/4, and we have to find the actual. So we're going to divide both of those by the scale factor. So 1 1/8 divided by 0.25, which is 4.5. And we're still talking inches. That didn't change. So this would be 4.5 inches. And then 1 1/4 divided by 0.25 gives us 5 inches. So here's the actual length and width. All right, let's try the last one. Example 4. The scale of the map is 1 inch equals 25 miles. So if the length of Lockport Road is 37.5 miles, find the distance of Lockport Road on a map. So this time we're going and actually finding the scale drawing length. So the scale is 1 inch equals 25 miles.